When we solve a system of linear equations, we look at a pair of equations of lines, and we try to find out if there are any ordered pairs that make both equations true at the same time. One way to do that is to just graph the lines, and if we can find a point that the two lines have in common, that point is the solution to the system of linear equations, because the x and y coordinates for that point will make both equations true at the same time. Another way to solve the same system of linear equations is a method called elimination. With elimination, we add the left sides of the equation and the right sides of the equation together to try to eliminate a variable. Once we do that, we can solve for that variable and then use that value to substitute into either of the equations to find a solution for the other variable. That pair of numbers for x and y is the solution to the system because the x and the y values will make both equations true at the same time. Another way to solve that same system is by substitution. In substitution, we make sure that one of the equations is solved for one of the variables, and then use that expression as a substitution in the other equation. That allows us to solve for one of the variables, and then we can use that value in the other equation to find the value of the remaining variable. Once we've got the solution, we know that the number for x and the number for y in the solution will make both equations true at the same time. Now that we've seen three methods for solving systems of linear equations, let's try another system. But fair warning, this one's going to be a little bit different. Let's start by solving it by graphing. So we'll graph the first line, x plus y equals 5. We'll graph the second line, x plus y equals 3. Those are parallel lines, so what's the solution? Well, if you have lines that never cross, that's called an inconsistent system, then there is no point that they have in common. So the solution is that there's no solution. Another way we can write that is with the empty set symbol. That means that there are no ordered pairs that make both equations true at the same time. When we have a graph, it's pretty easy to see that these lines don't cross, so there's no point that's in common to both lines. Now let's take this same system of equations and solve it using the other two methods we looked at. We'll start with solving by elimination. So with elimination, we'd like to be able to add the two equations together to eliminate a variable, maybe the y's. Well, we can see that if we try to add the equations right now, the y's will not be eliminated. So if we multiply the second equation on both sides by -1, we will have a y term that's the opposite of the y term in the first equation. So if we add those two equations together, we'll be able to eliminate the y's. But we also are going to eliminate the x's, which means we now have an equation that says 0 plus 0 equals 2, or just 0 equals 2. Well, that's a false statement. 0 does not equal 2, and that's the indicator to us that our equations represent parallel lines. That inconsistent system has no solution. So the key to knowing that you have no solution if you solve by elimination is if all the variables drop out of the equation and you simply have a number statement that's a false statement. In this case, 0 equals 2. Now let's take the same system and solve it by our third method, which was substitution. We'll take our first equation and solve it for y, and then substitute the expression -x plus 5 in the second equation for the y. Now on the left side, we'll combine like terms, and since the x and the minus x are opposite, they add together to give us 0. And once again, all the variables have dropped out of the equation, and we have a false statement. That false statement is our indicator that we have an inconsistent system, and an inconsistent system has no solution.